Okay. Oh, of course, it starts on the random slide that I didn't ask it to. I'm going to review just a little bit before we get started. So first things first, we're reviewing back to middle of last week. The sun shoots energy at us all day, every day. There are three things that control how much of that energy reaches Earth. What are the three things that control how much energy can make it to us? Zach. No, Zach, you're getting ahead of yourself. Do you have an answer? Yeah, so that was the same as what Carter said. So that's still getting ahead of yourself. So my question was, what controls how much energy reaches Earth? Radiation. Radiation is the energy coming at Earth. Angle of insolation. Insolation. So the first thing is the angle of insolation. So if the sun is high in the sky, we get more energy than if the sun is low in the sky. There's something else that controls how much energy we receive from the sun. So there's three things early down one. Oh, we're trying not to make eye contact. Radiation. So radiation is the energy coming from the sun. Okay, might need to pull it back in our brackets, people.
Yeah, but where is it? Because I can't find it.
Okay, so that's a good point. So can't find it in your notes. So what we're looking for is what controls energy received from the sun. So no, the electromagnetic spectrum is the energy received from the sun. Guys, flip back. I only see a few of you flipping or even trying. I'm gonna let everybody flip now. There are three things that control how much energy reaches Earth, how much insulation reaches Earth. When you're only laughing at your own joke.
How much the atmosphere absorbs every day?
Yep. So how much the atmosphere absorbs or lets through. For example, today, are we receiving a lot of energy from the sun today?
No.
No, why not? Because the cloud. So that's one. So we have the angle that the sun hits, how much gets through the atmosphere, and then the duration of insolation, which means how long the sun is in the sky. If the sun is in the sky longer, we get more energy. If the sun is not out long, we don't get a lot of energy. Then on Friday, we concentrated on angle of insolation. So we already know the higher the sun is in the sky, the more energy we receive from the sun. I actually have something that got brought up throughout the day that I want to make sure everybody understands. So we were talking about how high the sun is in the sky, and people were getting that confused with how close the sun is to Earth. And they are not saying the same thing. So if I say the sun is high in the sky, that doesn't mean it's close. Let me kind of do a quick demonstration, and I want you all to participate with me. Your nose is the sun. No, your nose is the Earth. Your fingertip is the sun. Can you put your fingertips straight above your head? Right now, everybody do this. Participate. Straight arms, please. Okay, so the sun is directly over your head. How much energy are we going to get from the sun if the sun is directly over your head?
No. Not more.
A lot.
A lot.
We're going to get a lot. Now, see how far away it is from your nose? It's a whole arm's length, right? Now let's put the sun low in the sky. Where would you go with the sun low in the sky? No, not this. The sun, guys, does the sun move like this throughout the day? Thank you. Straight out there, if you're pointing to the horizon, that means the sun is low in the sky. How far away is the sun from you now? Still an arm's length. Is it closer or farther away than when it was above? So my question is it any closer or farther away depending on where it is? No. So it's not, okay, that's all. It's not how far away the sun is, it's where it is in the sky. When it's directly over your head, a higher angle, it's going to be stronger. Remember when we held our flashlight? Did we do that in this class?
Yeah.
Okay, we held our flashlight directly over our table and we got bright light there. That's gonna be strong energy, a lot of energy. But when we held it off to the side, that light was spread out and wasn't as bright. That's gonna be less energy from the sun. So it's not how far or close it is, it's where it is in the sky, whether it's low or high or somewhere in between. So then on Friday, we talked about angle of insolation for the whole period. What are the things that will make the sun be in different spots? So what are the three things that control how high the sun is in the sky? Give me one, Keith. The season. So we talked about how in the summer, the sun is stronger than in the winter. Why is the sun stronger in the summer than it is in the winter? Because of the season, but my question is not, we already established that, but why is the sun strong? Because it's higher in the sky when it's in the summer. Okay, so that's one, season controls how high the sun is. What's another thing? Time of day. When is the sun hottest or strongest during the day? The middle of the day, the afternoon. Why? Because it's higher in the sky. So we've got time of day, time of year, and what's the third thing? The latitude, where you are on Earth. Who has stronger sunlight, us or Florida? Florida. And if you don't know that, ask yourself, where are you going to get the sunburn the fastest? Here or Florida? Florida. Because why? Why is it hot? Because the sun's higher in the sky. You caught on quickly, right? Or you weren't even here, you got up. The higher the sun, the stronger the sun, the hotter and the more sunburn you're going to get. That's besides the point. All right, so now we've covered angle of insolation. We're going to move on to duration of insolation. So first of all, what is duration of insolation? So if it's insolation, it's how long the sun is in the sky. So how long the earth is getting sunlight. What's another way of saying that, duration of insolation? No, this isn't a flip back thing.
How long the sun is out?
How long the sun is out. What's another way of saying how long the sun is out? How many daylight hours we have. Or another way that the Regents likes to word it is how long it is between sunrise and sunset, which just means how many daylight hours there are, or how many hours the sun is in the sky. So they word it differently, but you still need to come back to all it means is how long the sun is up. Now, how about this? There's two things that control how long the sun is in the sky. Now, wait, let me actually go back. Are you guys aware that the sun is out for different amounts of hours?
Yeah.
Different, okay, so where is it? Why is it out for different amounts? Let me try this again. What are the things that control how many daylight hours we get? There, when we have different amounts of daylight, it's because of different
Time of the year.
time of the year. Another way of saying different time of the year. Different season. When do we have more daylight hours? Spring and summer are more, well, let's go with just summer. So spring's more than winter. Spring and fall are actually exactly the same. But we have more daylight hours in the summer than we do winter. And then if you haven't noticed, spring and fall are the same. So our season will give us different amounts of daylight hours. And what's the other thing? Oh, no, I can't say.
I don't know.
You don't know? How about this? Does everybody in the world have the same amount of daylight hours? No. So it's your location again. So does anybody know how many hours of daylight they get at the equator? Not 24 at the equator, 12. The equator gets 12 hours of daylight. That's actually one of the reasons it's called equator. How do you spell equator? EQU, I don't know, the rest is not important. How do you spell equal? EQU and the rest isn't important. So you hear that? EQU, equator, equal. That'll be really helpful. So, okay, so you guys know everything already. So on the, I think it's page 13 now. Very top of page 13, duration of insolation. First, we're gonna put the definition, which you guys already told me. It's the length of time the sun is over the horizon. Again, that's how they're going to say it on the region. All it means is how long the sun is out, or again, how many daylight hours there are. So like, I think I said like 8 times now. They'll word this different, but it always means the same thing. All right, and then I think the next part we already covered. So it depends on latitude, so where on Earth, and the time of year, which is your season. So we're not gonna go into huge details. We're basically, you guys already know what you need to know. So here's the next part. So at the equator, there are 12 hours of daylight all year long. So they're lucky they don't have it like in winter like us, where we only have a little bit of daylight. But then if you ask me, they're unlucky because in the summer, they don't get those really long days. You know how you guys can go, like, you play a baseball game and it's 8 o'clock at night and the lights still don't have to be turned on? They don't get that at the equator. At the equator, the sun rises at 6 a.m., it sets at 6 p.m., and that's that. You could even notice it if you go to Florida. My cousins from Florida, when they would come up here, they would really notice it. They'd bring their little kids with them, and they'd say, they never go to bed because it's always daylight here. Because they weren't used to the sun setting at 8 or a little after 8. They were used to the sun setting around 7. Why did the sun set for them a little earlier in Florida? No, it didn't rise earlier when they're in Florida.
Yeah, that's not it.
Because they're close, I know what this means. It meant because they're closer to the equator, they have a lower latitude. It gets a little iffy, but then in the winter it goes back, and that's because of the season. So we'll go through these numbers. Winter's stupid. So, okay. Right, anyway. So the second part of this is your latitude. In the summer, one of the reasons it is summer is because we have those longer days, and if the sun is out longer, it heats up faster. In the winter, we have shorter days, which gives us cooler temperature. And that says as latitude increases. So as we go towards the equator, or towards the North Pole, we'll get these longer summers and shorter winters. So our summers, we have those longer days. Our winters, we have the shorter days. Combine that with your latitude, and Florida, their sun will come up and, oh my gosh, never mind. I'm struggling. It's not enough caffeine this day after daylight savings time. By the way, can I add the fact that daylight savings time is not what we're talking about here. So this duration, we still have the same number of daylight hours as we did yesterday. Technically, it's a little bit longer, but that's because of what day it is. But the daylight savings time does not affect how long the sun is out. It just which numbers it is on the clock.
No, it's going.
It's still out. We just can't see it because of that atmospheric transparency.
Did you go to TV over the weekend?
No, we didn't have time. We did go get our season's passes, but we didn't ski. Yeah, for next year. It's way cheaper then.
Oh.
I know you guys can't read them. Or maybe you can, but there's a lot going on here. So what I did is, this is last year's information, but it's very similar for 2023. So I pulled up April 1st in Buffalo and April 1st in Fairbanks, Alaska. So what did I change here?
The state.
Location.
The state, which is the location, which means I changed the latitude. So, well, we'll just use this little guy. We went from Buffalo, which is here, to Alaska, which is not quite at the North Pole, but a little bit south of the North Pole. So we changed latitude. On April 1st in Buffalo, the sun rises at 6:57 a.m. in Buffalo. Sets at 7:41 in Buffalo, which means on April 1st, we'll have 12 hours and 44 minutes of daylight. In Alaska, on April 1st, their sun rises at 7:06, a little after us, but sets at 8:44, giving them almost an hour more daylight than us. They get 13 hours and 38 minutes of daylight on April 1st. What?
I'd rather have
You'd rather have 12, okay, well, good to know.
13 is too long.
Now I want to point something out. Every day, the sunrise and sunset changes a little bit. If we're getting closer to summer, what happens is we get more hours of daylight. So just one day's difference. The sun will rise 2 minutes later in Buffalo. So we go from, or earlier, sorry, 6:57 a.m. on April 1st to April 2nd, 6:55 a.m. Then the sun sets a minute later. So we get a total of 3 more minutes of daylight in just one day. Okay, Alaska they get, the sun rises 4 minutes earlier, sets 3 minutes later. So they get 7 more minutes of daylight in just one day. So that's April 1st. Keep in mind the numbers. 12:44 hours of daylight for us, 13:38 for Alaska. So now we're gonna go to June. We're gonna go to June 21st. Does anybody know why I picked that day?
That's the most daylight.
It is for the Northern Hemisphere. The most hours of daylight, that will be the very first day of summer. We get 15 hours and 22 minutes. I know Zach doesn't like that. He'd rather have 12. We're getting 15 hours of daylight. The sun doesn't set until almost 9 o'clock, 8:57. Oh wait, that's not even the first day. 8:57. In Alaska, however, they get 21 hours, 49 minutes, and 43 seconds. Zach, how does that make you feel?
No thanks.
Okay?
What's the temperature there though?
This chart does not have the temperature, but let's talk about this.
3 hours of daylight?
No, 23 hours of just daylight,
21.
21 hours of
3 hours without daylight.
3 hours without. Is that what you said?
Yeah.
I'm sorry.
Don't they go through a thing where at one time it's always dark and then
So let's turn to December 21st. I think I picked that day.
It's
It's the least amount. It's the first day of winter. So here we go. Our sunrise, 7:43. Our sunset, 4:44. Giving us only 9 hours and 1 minute of daylight. Then, here we go. 10:58 a.m. is their sunrise. Their sunset is 2:40 p.m.
That's like no hours.
That is like 3 hours and 41 minutes and 42 seconds of daylight.
You actually just still do it.
No, it's right there,
Oh.
like right there, like all of them on there.
I was gonna say, you just calculated.
I did, I'm amazing. I shouldn't have messed up. I'm just that good. So what do you think? I mean, know how Zach feels. We're actually, Zach, what do you feel about this? 3 hours and 41 minutes of daylight.
That's too little.
That's too little.
I
Geez,
think
you're
like-
never happy.
7 or 8 is pretty fine.
Less than we get, and you don't want that as much as we get.
9 hours.
That's
is
like
one
a
of the days
school
of-
day.
Yep, 9 hours and 1 minute is the shortest amount of daylight we ever get. That's in December. You like that? Where
Yes, I love when.
you like when the sun rises after school, we're in school and sets only a couple hours after? Wow, you're crazy. Sorry, that was me putting my feelings onto you,
I
sorry.
mean, well, technically, none of it matters, because like after I got out of sports and it's already dark, so. anyway,
Not in the
really,
summer?
Daylight don't matter, yeah.
Okay, but I just wanted to show you how drastic it was from Buffalo to Florida, or Buffalo to Alaska, showing you the difference.
Some traffic here.
If we had pulled up, and that's, we'll do that another time. If we had pulled up the equator, it would have been 12 hours the whole way across. So what this again means, and you already wrote this, as we get closer to the closer to the pole, those seasons will be very drastic. Longer summers, the farther away from the pole, oh my gosh. The farther away from the equator you are, the longer the summers and the short daylight hours, and the shorter the days are in the winter. Want to see what this might look like if you lived there? Here is what a winter day would look like in Alaska, sunrise to sunset. This is Fairbanks, 3 hours and 49 minutes. This is the whole day. Okay, 10:58 a.m. The sun is just beginning to rise. I want you to notice a few things about the sun in this day in Alaska.
I see going to the right.
The sun is rising. If you haven't noticed, the sun rises in the east. That's in the west. So you've never heard that saying, rise in the east, that's in the west. Have you ever not ever gone and looked at the sky during the sunrise?
Good video game.
Oh, okay, as long as we understand. So yeah, part of the sun rises in the east, that's in the west. That's next chapter anyway, you'll learn.
You never do that.
Here's noon. So that's the highest the sun ever gets in the sky on this day. Do you know this?
Oh.
Not that high. So the angle of insolation is super low in Alaska.
5 degrees.
That's not even 45. Here's the horizon. Here's the horizon going to there. That is not very, that's like there. It's like,
23 degrees.
not even, I know. Well, I guess 23 would make sense, but I don't think it is.
And on June 21st in New York, is the sun 90 degrees?
No, in fact, in New York State, the sun is never directly overhead. We talked about that on Friday.
July 4th is like.
No. No, June 21st would be the highest. July 1st, or July 4th isn't too far from that. Sunset, 2:47 p.m.
Why was it 26 degrees?
What is it?
Yeah,
Well, it wasn't temperature.
no, it was the direction. So within a compass from 0 to 360 degrees, that's where it is on a compass. Almost at 360 degrees. Oh. No, not quite. It's like, yeah, but it's closer than like 90 degrees or 28.
All right.
Yeah, answer this question.
Well, if you notice, that's part of your homework. We're gonna move on to page 14 now. So your homework is to do those, what was there, 3? 4 questions?
3.
Do those 3 questions for homework. Now we're moving on to atmosphere transparency.
So we have homework.
There's 13 and 16 up there. Let's wait and see if we get to 16. So we're gonna start talking about atmosphere transparency. Again, how see-through this atmosphere is. So you've got this exact picture in your packet. We're gonna start with, at the very top, it says 100% incoming solar radiation. That's insolation. So you've got 100% of the energy the sun is shooting at the earth. Then what happens to that 100%? No, I'm gonna go through it.
Oh,
To start off with, about 24% is reflected by dust particles. Guys, what does reflected mean?
thank you, Amir.
Okay, a mirror
Your
reflects.
reflection.
You can see your reflection. So what does that mean is happening to the sun if it's reflected by the cloud?
It's not coming down, it's going back up.
There, it's not coming down, it gets shot back up. And you can see that on the picture here. It's hitting the cloud and bouncing back off into space. Guys, I'm gonna tell you, these numbers are not the important part of this, this set of notes. The numbers are there just to give you an idea that right now, about half of it is not even making it to Earth. 24% gets bounced back into space. About 25% the clouds actually absorb, and they warm up the clouds. So the key here is that about half of it doesn't even make it through the clouds.
What is that? They absorbed by what?
Absorbed by clouds and dust particles in the atmosphere. The other one was reflected. So if something's absorbed, what does that mean? Yeah, soaks into it. And if we're absorbing sunlight, what do you think's gonna happen?
Or take a stroke into it to give it sunburn.
Okay, I was getting at it's gonna warm us up, but yep, if it's soaking into us, we would get a sunburn, sure. All right, so now we've got about 50% making it through the clouds. And what happens is some of it hits Earth's surface and bounces back into space. So it says about 8% is reflected by Earth's surface. What on Earth could reflect sunlight back into space? What? A mirror could. So if the Earth was covered in a mirror, we'd reflect a lot. Earth is not covered in a mirror, but what things on Earth act like a mirror?
Cars.
Okay, so cars, but let's do an actual Earth. Water. Ever been on a boat
Yeah.
and noticed how much the sunlight bounces back into your face? That's one thing. What's another thing that will reflect, that it acts like a mirror? Guys, stop. What's another thing on Earth that acts like a mirror? Snow. On bright sunny days, what's it look like when there's snow on the ground?
Super bright.
Super bright, more bright than days when there isn't snow on the ground, because that snow is shiny and the light bounces back into your eyes. So when the light hits some objects, it reflects the light back into space. Other times it hits the Earth and gets absorbed. If energy gets absorbed by the Earth, what are some things that'll absorb some sunlight? The ground, particularly what parts of the, like what kinds of ground? Grass is the other thing on the ground that'll absorb a lot of heat. Ponds, we just said reflects it, like, we look outside right now, what surfaces out there will absorb sunlight, if there was sunlight? Yeah, said that already.
Blacktop.
Blacktop. Blacktop will absorb heat. You guys know that?
Yeah, because when you walk on it, it's really hot.
Because when you walk on blacktop, it's really hot. Even on days where it's not super warm out, if it's sunny, the blacktop heats up. That's why right now, why is the snow not sticking to the road out there? Because the blacktop is warmer than the ground. Yeah.
Isn't the color black in general, like,
Yeah.
like they just absorb?
So speaking of that, we're gonna move on to the next part that's talking about dark surfaces versus light surfaces. So right on the bottom of the same page, still on page 14.
You don't wear black in the summer.
Great, why don't you wear black in the summer, or what?
The heat.
Because it absorbs the heat. Why did the black leather seats of my car get so hot? Because it absorbed the heat. So we know, you already knew that. That was not news to you, that dark surfaces absorb the greatest amount of heat. The first bullet says absorb the greatest amount of heat. But then the second bullet says radiates the greatest amount of heat. What does radiates heat mean? If you're radiating heat, what are you doing? Kind of, you're giving off heat. Not, I want you to think it's quite the same thing, but I knew what you meant. If you're radiating heat, you're giving off heat. So blacktop. And I would go outside and do this with you, but it's not gonna happen today because, well, there's no sun. But you guys know this, blacktop gets hot, right?
Yeah.
You ever been near blacktop and not touched it, but felt the heat pouring off of it?
Like in the summer, if
Yeah.
you go out on a football field, you look like down the field, you can see the track, you can see the heat on it.
Yes, exactly that. So the track's pretty hot, right? And it's also giving off a lot of heat. So things that absorb heat really well will also give off heat really well. So those black surfaces absorb a lot of heat, but they also give off a lot of heat versus the light stuff. They're gonna reflect more. So this is why white shirts are better off, because the sun doesn't get absorbed, it bounces off. And because they don't absorb a lot of heat, they don't radiate a lot of heat. So we are just gonna have page 13 as homework. We're not done yet, but I'm telling you, we're not getting to 16.
Oh my goodness.
And the last thing we're gonna do for today, we're gonna talk about rough surfaces versus smooth surfaces. What happens, you think, when sunlight hits rough versus smooth stuff? What do you think?
Rough is gonna absorb it.
Rough is going to absorb it. That surface area that rough makes is going to cause it to absorb more. Well, I gotta talk about what's a rough surface. What would you guys have considered a rough surface outside?
Concrete.
Rocks, concrete, okay? How about the beach?
Oh, yeah.
Huh? What about sandpaper? Is sandpaper rough?
Yeah.
So then why is the beach not rough?
Because
Because you have double standard.
It is.
Sand is sand.
Because when you walk on the beach on hot days, the sand is hot.
That was what I was gonna ask. So you agree sandpaper is rough, right? Sand is just sandpaper without the paper and the glue gluing it on. It's not the paper that makes sandpaper rough, it's the sand that makes it rough. If you had just a few pieces of sand in your fingers and went like this, would you have said sand is rough? Mm-hmm. So sand is rough. The way it works, yes, it feels nice on our feet, but you do know that sand itself is rough, and that's because sand is just a bunch of little tiny pieces. And those little pieces are going to absorb the heat more than anything else. So that's why, as Sarah said, when you walk on the beach in the summer, that sand is hot because it's rough and absorbs the heat. The smooth surfaces, we're going to have less heat absorbing in those. And that is where we're going to leave off for today. Why don't you guys go to page 13 and do your homework? There's only 3 questions, so actually try.